Welcome everyone to this live podcast on Twitch, where you can find news from the research industry that how our researchers keep on researching on various topics and domains to keep our lifestyle better and useful, of course. And this article posted on our website named postscientist.com. So if you are willing to check it out, please check it out. Otherwise, listening to this podcast will be enough for you guys as it acts like an archive on the daily basis, providing you the information from the research industry itself. So let's get started without wasting any further time. Double trouble when two disasters strike electrical transmission infrastructure. Okay, let's see. One natural disaster can knock out electrical service to millions. A new study suggests that back to back disaster could cause catastrophic damage, but the research also identified new ways to monitor and maintain power grids. Researchers at the Ohio State University have developed a machine learning model for predicting how susceptible overhead transmission lines are to damage when natural hazards like hurricanes or earthquakes happen in quick succession. An essential facet of modern infrastructure, steel transmission towers help send electricity across long distances by keeping overhead power lines far off the ground. After severe damage, failures in this system can disrupt networks across affected communities, taking anywhere from few weeks to months to fix. The study published in the journal Earthquake Engineering and Structural Dynamics uses simulation to analyze what effect prior damage has on the performance of these towers once a second hazard strikes. The findings suggest that previous damage has a considerable impact on the fragility and reliability of these networks if it can't be repaired before the second hazard hit, said Abdullah Shif- Shifizadeh, co-author of the study and assistant professor of civil, environmental and geodetic engineering. Our work aims to answer if it's possible to design and manage system in a way that not only minimizes their initial damage but enables them to recover faster, said Shafia Zadeh. The machine learning model not only found that a combination of an earthquake and hurricane could be particularly devastating to the electrical grid, but that the order of the disaster may make a difference. The researcher found that the probability of a tower collapse is much higher in the event of an earthquake followed by a hurricane than the probability of failure when the hurricane comes first and is followed by an earthquake. That means while communities would certainly suffer some setbacks in the event that a hurricane precedes an earthquake. A situation wherein an earthquake precedes an hurricane could devastate a region power grid. Such conclusions are why Shifat Zadeh, Shafi Zadeh research has large implications for disaster recovery efforts. When large scale power grid systems are spread over large geographic areas, it's not possible to carefully inspect every inch of them very carefully, said Shafizadeh. Predictive models can help engineer or organization say which towers have the greatest probability of failure and quickly move to improve those issues in the field. After training the model for numerous scenarios, the team created fragility models that tested how the structure would hold up under different characteristics and intensities of natural threats. With the help of this simulation, researchers concluded that tower failures due to single hazardous event very vastly different from the pattern of failure caused by multi-hazard events. The study noted that many of these failings occurred in the leg elements of the structure, a segment of the tower that help bolt the structure to the ground and prevents collapse. Overall, Shafizadeh said his research shows a need to focus on re-evaluating the entire design philosophy of these networks. Yet to accomplish such as tasks much more important from utilities and government agencies needed, of course. Our work would be greatly beneficial in creating new infrastructure regulation in the field. Shafizadeh said this along with our other research shows that we can substantially improve the entire system performance with the same amount of resources that we spend today just by optimizing their allocation. Hmm. I mean, great man. Moving on to our next topic, a path to human like machine intelligence. Okay, let's see. Artificial and machine intelligence are changing the way we live more and more each day. Manufacturing robots, self driving cars, and virtual travel booking agents are just a few examples of how these technologies have permeated our world, according to John Paul, Associate Professor in Bradley Department of Electrical and Computer Engineering. Even with the notable advancement in machine intelligence over the last few years, we have just begun to scratch the surface. To continue on the path to true machine intelligence, Paul has been awarded a National Science Foundation award to investigate methods to design a computer architecture that emulates the way the human brain operates. The Virginia Tech faculty member whose research focuses on brain inspired computer architecture is the sole principal investigator of the $400,000 project and hopes to help lay the foundation for what could potentially be a revolutionary understanding of true machine intelligence. In its current form, artificial intelligence is a misnomer. No current form of computing is actual intelligent, said Paul. In order for true machine intelligence to come into being, it must exhibit common sense and creativity as these are required for general intelligence. The human brain can simultaneously process several incoming stimuli of different quality. A recent article in Nature explained that this level of information analysis is known as parallel processing, something that researchers have been trying to emulate in computing for quite some time. Paul research focuses more specifically on another capability of the human brain tackling a paradox. So, what is a paradox? When it comes to information processing in the brain, it can be described as the brain way of accommodating conflict at the highest levels. According to Paul, when the human brain processes conflicting information, it uses parallelism to deal with uncertainty and ambiguity, provide the foundation for creativity in the way we think. Creativity is the result of seeing things multiple different, even contradictory ways, said Paul. Paradox is the quintessential example of a contradiction. So, we will research algorithm architecture, solution to problems that produce completing result and understand how those can be accommodated and also continuously evolve and thus lay the foundation of creativity. One of the challenges of this research will be coming up with the fundamental problems to illustrate applicable concept. For this research, Paul is focusing on how the brain uses compar- compartmentalization but also may access multiple compartments for the same set of inputs or the same situation. This ability may be the key to how the brain uses such high levels of parallelism while also accommodating ambiguity and conflict. An example would be when two bilingual people have a conversation. If one person speaks a single sentence that contains both French and English words, the sentence might be processed in separate regions of the brain, one of each language. Each corresponding region must conclude whether the sentence is French or English. However, the sentence is actually both and neither, said Paul. The listener must decide what the speaker actually means, especially if there is phonetic ambiguity in what is being said. said Paul. In doing so, they must resolve the conflict and the ambiguity, all while keeping their language center from becoming too large and inefficient. By better understanding the way the human brain processes information, Paul hopes to apply those same principles to computer architecture, leading to an understanding of the structural mechanism behind true machine intelligence. Machine and artificial intelligence still rely heavily on algorithm to make decisions, but following these rules does not produce a human-like result, as most of us have learned through trial and error. Most problems have more than one solution. Over the course of the 3 year award cycle, Paul and graduate student Isaac Bentendorf will conduct experiments that feature problems with multiple algorithmic solutions that are similar to what a person might encounter on a daily basis. Those algorithms will help form the basis of a high level foundation for a new architecture capable of accommodating high degrees of parallelism and resolving conflict resolution. Bentendorf is currently pursuing a Master of Science in Computer Engineering. He enjoys the challenges of this particular research and the new perspective it has given him as an embedded system engineer for the US Navy at Dell Green. The research that I'm performing with Dr. Paul is providing fundamental new ways of looking at computing. It's an honor to work with her, said Bentendorf. Developing technology for the Navy has provided me with a wide range of opportunities. I have developed and implemented solutions using both integrated circuit or microcontroller unit environments and have experienced many of the limitations addressed by the research and by Dr. Paul and me. In many ways, this has motivated me to take a step back to try and see the bigger picture and address these limitations from a different point of view. In addition to the research, Paul will create a magazine style article to educate audiences without STEM backgrounds. The article will focus on the difference between computer architecture and human intelligence by describing the future use of personal avatars and how they could one day be making decisions for us, especially if those avatars are capable of coming up with creative solutions to problems. The fundamental question are exciting what is most exciting, said Paul. I'm not an excited by applied research. For me, true research does not provide a tool or a solution so much as it provides the basis and stimulus to see things entirely differently. So these are the study uh, uh, given by our scientists on this time grounds. So I mean, great man. Moving on to our next topic: new efficient phase change micro capsule for storing solar energy. Hmm. It is no news that society dependence on non-renewable fossil fuel has led to the ongoing global energy and climate crisis. The emission from coal, natural gas, and petroleum-based fuel are major contributors to air pollution. In turn, global warming in society attempt to shift to a sustainable carbon-neutral energy income economy. Solar energy holds much promise. Abductant and eco-friendly solar energy, if harnessed efficiently, can reduce our dependence on conventional sources of energy. In this regard, phase change material PCM substances will release absorb sufficient energy at phase transition in the form of latent heat to provide useful heating cooling are a popular candidate as solar energy storage devices. Studies have shown that a solar powered PCM based cooling system can reduce the ambient temperature by 30 degrees Celsius. Unfortunately, practical PCMs suffer from linkage and corrosion issues. Moreover, they show poor heat transfer properties owing to low thermal conductivity. While this can be solved by using metal PCMs, it makes the PCM costlier and bulkier. One way around this issue, as studies have shown, is to encapsulate the PCM in microcapsule with high conductivity fillers such as nanoparticles. This can protect them from the damaging effects of light, heat, moisture, and oxygen, as well as improve the heat transfer properties. Additionally, many researchers have resorted to low density non metallic high thermal conductivity nanoparticle for this purpose, which avoid the issue of metallic nanoparticles. In a recent breakthrough, researchers from China and US synthesized PMC microcapsules showing unprecedented photothermal conversion and heat transfer by using an octadecane ODE as the PCM code and a silicon carbide nanoparticle dope cross-link polystyrene CLPS as the outer shells. Phase change microcapsule material have been the focus of our research. In a previous study, we found that a single organic shells has defects in thermal conductivity and stability, while a single inorganic cell is not satisfactory in compactness and coverage. Therefore, we began to focus on doping organic shells with inorganic nanoparticles to obtain organic inorganic hybrid shells, explained Professor Jifen Wang from Shanghai Polytechnic University, China, one of the authors of the study, which was published online on September 29, 2022, in Energy Storage and Saving. In their work, the team prepared a series of 4 microcapsules using a method called suspension polymerization. They then characterized the microcapsule using scanning, electron microscopy, energy dispersive X-ray spectroscopy, and Fourier transform infrared spectroscopy. The result indicated that the microcapsule were spherical and the known Si carbon, silicon carbon particles were embedded in the cliff CLPS clips shells, aiding the heat transfer and photothermal conversion efficiency of the microcapsules. The team next tested the thermal properties of the microcapsule and found that they showed superior photothermal conversion and thermal conductivity compared to the non-dope samples. Among the 4 types of dope microcapsules, the one with 1.25 weightage nano silicon carbon doping demonstrated the best performance with a 54.9% photothermal conversion efficiency, 146% higher its non-dope counterpart. With such encouraging result, the novel PCM microcapsule shells could provide a solid framework for further research on energy material with excellent solar energy storage and conversion efficiency. The study also opens new doors to the practical application of multifunctional phase change microcapsules. These microcapsules can have significant potential application as energy storage materials in solar energy devices, intelligent thermal insulation equipment, and energy saving buildings. I mean, great man, great for the professor, great for the PCM students, and of course for the doctors, and it's going to be used in many bio related things. And yes, moving on to our next topic, solid state processing of surplus aluminum alloy powders. A project led by Dr. Simon Graham, a research associate, EPR SRC MAP Future Manufacturing Hub combines field assistant sintering technology fast with hot rolling to convert surplus aluminum alloy powders from atomization into sheet material in solid state steps. Metal additive manufacturing AM techniques typically operate using powder with limited particle size ranges in the atomization process, where the melted metal alloys are first refined and degaussed, then poured into a gas nozzle where the liquid material is disintegrated into metal powder by a high pressure gas stream. Significant amounts of particles are produced outside of these ranges. This results in an accumulation of out of size specification metal powders without a clear use case. In addition to many other sintering methods have been found to be ineffective in the consolidation of aluminum powders. AM techniques are generally promoted as having reduced material wastage compared to conventional metallurgy, where extensive machine machining waste is generated, but the as atomized particle size range is often overlooked as an issue. Business economics requires that alternative processes are utilized to convert these surplus powders into useful product to ensure that the aim market is cost effective and meets the sustainability targets. This key factor informs the foundation of this research. Field assisted sintering technology can provide an alternative solid state processing route to consolidate the surplus powder into billets for subsequent processing. This enables the production of a useful product from this feedstock, whilst also improving sustainability within the AM supply chain. This project goes a step further in combining fast with hot rolling to convert surplus aluminum alloy powders from atomization into sheet materials into solid state steps. Fast can effectively consolidate the powder into fully dense billets, which are then hot rolled into sheets. Through tensile testing, the result revealed that the properties output from this process were comparable to conventional material which is used in aerospace applications. Pre-existing research focused on fast of metal powders has assisted in the development of this project. This spearhead a final year student project designed by Dr. Garam and led by Alicia Patel. Bang Aerospace engineering student also assisted in the practical work in the early stage development of research direction prior to defining this project. Following the completion of this early stage research, the project has been built upon with a more streamlined direction, which is led by Dr. Simon Graham. The works have also been informed by works carried out in Sheffield relating to the processing of titanium powders, which are oversized for laser powder bed fusion, where methods of crossover were identified to be of relevance. When reviewing existing literature, only one paper has been published which specializes on hot rolled, fast produced pure aluminium. Previously published research on A20X alloy has only considered AM or cast material. It has been shown that fast can rapidly consolidate aluminum alloy powders, including A20X, with a large particle size range into fully dense material. The resulting 80 mm diameter A20X fast were also successfully hot rolled from their initial 15 millimeter thickness down to 2 millimeter sheet. Although some later optimization is required to prevent edge defects within the sheet, some conventional cast A20X material with the same starting dimension were also hot rolled under the same conditions. Tensile testing showed that before and after the heat treatment, the fast material exhibited similar property to the cast and were comparable to other aluminum sheet used in aerospace application. This finding was presented by Dr. Simon Graham at World PM 2022 conference in a keynote titled Solid State Processing of Surplus Aluminum Alloy Powders. Through a combination of field assisted sintering technology and hot rolling, the result was a promising step in creating high performance sheet material from surplus aluminum alloy powders, with some further optimization and scale up required. The outcome of this project has demonstrated that there is a viable processing route to convert surplus alloy powders into sheet material with a good mechanical properties. Although the long term positive impacts cannot be quantified at this stage, there are clear economic impacts. These economic benefits relate to new revenue streams for atomizers as well as potential cost reduction of powders for AM. The next step involved completing further rolling trials to optimizing the processing and produce higher quality of sheet product. These sheets can also be extended in the starting phases in a bid to produce larger sheets as an output, which further demonstrates scale up opportunities. Super plastic forming of the sheet material could also be considered to produce near net shape components. So these are the findings given on the solid state processing of surplus amount of energy and the mechanical properties, and of course in going to be used in various applications. So yep, moving on to our next topic. Not keeping up with the Jones, the one factor that makes us less likely to emulate our neighbors on climate action. Okay. About 30% of Australian homes have rooftop solar panel installed, the highest uptake of any nation. Their popularity has been helped along by government subsidies that reduce the upfront cost of the technology, but these subsidies may not always have a positive climate impact. While people like to keep up with the Jones on climate action, by my recent research suggests this is not always the case when large solar subsidies are being offered. It found if someone is perceived as having installed solar panels primarily for a financial benefit, their non-solar neighbors may actually be deterred from reducing their own climate impact, such as by signing up for so-called green retail electricity schemes. Subsidies are often a policy go-to for governments wanting to encourage more climate-friendly behaviors, but my findings indicate they should be used with caution. A spotlight on buyer behavior. Examining subsidies for rooftop solar system is valuable because it can tell us about consumer behavior more broadly. For the past 20 years or so, state and federal governments have subsidized the cost of installing rooftop solar by offering a range of rebates and other financial incentives to consumers. In recent years, these subsidies have fallen in part because the cost of technology has become so cheap that consumers can recoup the cost fairly quickly through reduced power bills, but some subsidy for rooftops, solar and home batteries still exist. Some governments also apply them to energy efficiency measures and electric vehicles. Such subsidies come at great cost to the public purse, so they will help Australia reach its emission reduction targets. My research suggests in some cases they can be counterproductive. Signing up from green power, neighbors influence each other behavior. Living near lots of homes with solar panels can change people belief about the signs of climate change. It also make people more likely to install solar panel on their home. However, research focused on water conservation suggests that peer pressure effect is muted if the behavior change doesn't also come with a financial benefit. There remain gaps in our understanding of how neighbors influence each other's energy use. For example, we don't know if installing solar panel influences the energy behavior of people who can't install panel because, say, they live in an apartment. My research examined the uptake of green power to help us close the knowledge gap. Green power is a government aggregated electricity generated by renewable sources and are offered for sale to consumers. Like installing solar panel, green power can be considered a public good in that it helps tackle climate change, but green power is not subsidized and is not visible to neighbors, and users also don't get the financial benefit for selling surplus electricity from rooftop solar back to the grid. The number of green powered users in Australia has fallen dramatically in recent years, from about 1 million customers in 2009 to 100,000 in 2019. Much of this may be explained by people switching to rooftop solar during that period, but it was also possible that rooftop solar installations were influencing decisions by non solar neighbors of whether to sign up to green power schemes. my research aimed to distinguish between these possibilities. What the research found: I studied the electricity plan choices of about 300,000 300,000 customers in Victoria from 2009 to 2016. I matched each contract to the number of solar panels installed in the postcode. In the quarter, the contract was signed. I found an average solar panel installation increased the number of non-solar homes purchasing green power, but economic incentives like subsidies actually reduce the peer effect. During periods of high solar subsidies, an additional 1,000 homes with solar panels reduced the share of green power contracts by 0.08 or 400 for every 5,000 new electricity contracts taken out by non-solar customers. During period of low solar subsidies, an additional 1,000 homes with solar panel increased the share of green power contract by 0.02 or 100 of every 5,000 new electric contracts. This suggests economic incentive compromise the signal that a neighbor is acting in the public good and so reduce pressure on neighbors to follow their lead. Of course, this may then mean behavior neighbors feel less pressure to address their own electricity related greenhouse emission by purchasing green power or taking other climate friendly measures. Other factors are also likely to have contributed to the decline in the popularity of green power. This include its cost relative to electricity from other sources and debate around the introduction and removal of Australia carbon price. I mean, great man. Proceed with care. Subsidies affect technology adaptation, and subsidies for green technology such as solar panels do lower carbon emissions. But subsidies also have indirect effects that must be considered when thinking about the cost and benefit of various policy options. Alternatives to these subsidies exist. This include an economic wide price on carbon emission, ceiling on vehicles, and mandatory renewable energy targets. This policy option could avoid the downside of subsidy to consumers. I mean, it's great, and it's being used for many in the energy storage and for making the electricity and various application to store the energy and break the difference between the local people to the scientists. So I mean, great man, great finding, great research. Moving on to our next topic: deprogrammable materials selectively self-assemble. While automotive manufacturing is ubiquitous today, it was once a nascent field birthed by inventors such as Oliver Evans, who is credited with creating the first fully automated industrial process in flour mill. He built and gradually automated in the late 1700s. The process for creating automated structure or machine are still very top down, requiring human factories or robots to do the assembling and making. However, the way nature does assembly is ubiquitously bottom up. Animals and plants are self assembled at a cellular level, relying on protein to self fold into target geometries that encode all the different functions that keep us tickling for more. By inspired bottom up approach to assembly than human architecture, materials need to do better on their own, making them scalable, selective, and programmable in a way that can mimic nature. Versatility means some teething problems though. Now, researchers from MIT Computer Science and Artificial Intelligence Laboratory (CSAIL) have attempted to get over these growing pains with a new method introducing magnetically reprogrammable material that they called different parts with like robotic cubes to let them self-assemble. Key to this process is a way to make these magnetic programs highly selective about what they connect with, enabling robot self-assembly into specific shape and chosen configurations. The soft magnetic material coating the researcher used sold from inexpensive refrigerator magnets endorse each of the cube they built with a magnetic signature on each of its faces. The signature ensured that each face is selectively attractive to only one other face from all other cubes in both translation and rotation. All of the cubes, which run for about 23 cents, can be magnetically programmed at a very fine resolution. Once they are tossed into a water tank, they use 8 cube for a demo with a totally random disturbance. You could even just shake them in a box. They will bump into each other. If they meet a wrong mate, they will drop off, but if they find the suitable mate, they will attach. An analogy would be think of a set of furniture parts that you need to assemble into a chair. Traditionally, you need a set of instruction to manually assemble parts into a chair, a top-down approach. Of course, man. But using the research method, these some parts once a program magnetically would self-assemble into the chair using just a random instrument that makes them collide. Without the signature they generate, however, the chair would assemble with its legs in the wrong places. Okay, man. This work is a step forward in terms of resolution, cost, and efficiency with which we can self-assemble particular structure, says Martin Nisard, a PhD student in MIT Department of Electrical Engineering and Computer Science (EECS), an affiliate of CSAIL, and the lead author on a new paper about the system. Prior work is a self-assembly has typically required individual parts to be geometrically dissimilar, just like puzzle pieces, which required individual fabrication of all the parts using magnetic programs. However, we can bulk manufacture homogeneous parts and program them to acquire specific target structures, and importantly reprogram them to acquire new shapes later on, which on without having to refabricate the parts anew. Using the team magnetic plotting machine, one can stick a cube back into the plotter and reprogram it every time the plotter touches in the material. It creates either a north or south oriented magnetic pixel on the cube's soft magnetic coating, letting the cubes be repurposed to assemble new target shapes when required. Before plotting a search algorithm to check each signature for mutual compatibility with all previously programmed signatures to ensure they are selective enough for successful self-assembly. With self-assembly, you can go their passive or active route. With active assembly, robotic parts modulate their behavior online to locate, position, and bond to their neighbors, and each module needs to be embedded with hardware for the computation, sensing, and actuation required to self-assemble themselves. What's more, a human or computer is needed in the loop to actively control the actuator embedded in each part to make it move. While active assembly has been successful in reconfiguring a variety of robotic systems, the cost and complexity of the electronics and actuators have been a significant barrier to scaling self-assembly hardware up in neighbors and down in size. With a passive method like this researcher, there is no need of embedded actuation and control. Once programmed and set free under a random disturbance that gives them the energy to collide with one another, they are on their own to shapeshift without any guiding intelligence. If we want a structure built from hundreds or thousands of parts, like a ladder or bridge, for example, you wouldn't want to manufacture a million uniquely different parts or to have to remanufacture them when you need a second structure assembled. The trick the team used toward this goal lies in the mathematical description of the magnetic signature, which describes each signature as a 2D matrix of pixels. This matrix ensures that any magnetically programmed parts that shouldn't connect will interact to produce just as many pixels in attraction as those in repulsion, letting them remain agnostic to all mating parts in both translation and rotation. While the system is currently good enough to do self assembly using a handful of cubes, the team wants to further develop the mathematical description of the signatures. In particular, they want to leverage design heuristics that would enable assembly with very large numbers of cubes while avoiding computationally expensive search algorithms. Self-assembly processors are ubiquitous in nature, leading to the incredible complex and beautiful life we see all around us, says Howard Lipson, the James and Sally Scapa Professor of Innovation at Columbia University, who was not involved in the paper, but the underpinnings of self-assembly have baffled engineers. How do two protein dis, uh, destined to join find each other in a soup of billions of other proteins? Lacking the answer, we have been able to self-assemble only relatively simple structures so far, and resort to top-down manufacturing for the rest. This paper goes a long way to answer this question, proposing a new way in which self-assembly building blocks can find each other. Hopefully, this will allow us to begin climbing the ladder of self-assembled complexity. Moving on to our next topic, engineer develop sensor for face mask that help gauge fit. Okay, man. Let's see. Wearing a mask can help prevent the spread of viruses such as SARS-CoV-2, but a mask effectiveness depends on how well it fits. Currently, there are no simple ways to measure the fit of a mask, but a new sensor developed at MIT could make it much easier to ensure a good fit. The sensor, which measures physically contact between the mask and wearer face, can be applied to any kind of mask. Using this sensor, the researcher analyzed the fit of a surgical mask on male and female subjects and found that overall the mask fit women faces much less closely than they fit man faces. When we realized by analyzing our collected data from the individual in the study was that the masks that we use in daily life are not very suitable for female participants, says Canon Dag Devlin, the LG career development professor of media arts and science at MIT and the corresponding author of the study. The researcher hoped that their sensor will help people to find masks that fit them better, and that designers could use to create masks that fit a wider variety of face, shapes, and sizes. The sensor can also be used to monitor vital signs such as breathing rate and temperature, as well as environmental conditions such as humidity. The study is a collaboration between Dag Davidian Lab, Siki Zhang, the STL champion professor of urban and real estate sustainability in the Department of Urban Studies and Planning, and the Togla Durek, managing director of MIT Environment, Health and Safety Program. Jin Hun Kim, a MIT postdoc, is the lead author of the paper, which appears today in Nature Electronics. Moving on to the next topic, fit quality. The researcher began working on this project before mask wearing become more common during the COVID-19 pandemic. Their original intention was to use sensors embedded in masks to measure the effectiveness of mask wearing in areas with high level of air pollution. However, once the pandemic started, they realized that such a sensor could have more widespread applications With so many different kinds of masks available during the pandemic, the researcher thought this kind of sensor could be useful to help individuals find the best fitting mask for them. Currently, the only way to measure mask fit is to use a machine called a mask fit tester, which evaluates the mask fit by comparing air particle concentration inside and outside of the face mask. However, this type of machine is only available in specialized facilities such as hospitals, which use them to evaluate mask fit to for healthcare workers. The MIT team wanted to create a more user-friendly portable device to measure mask fit. DAC Devian Lab, the conformable decoders group, specializes in developing flexible, stretchable electronic that can be worn on the skin or incorporated into textile to detect signal from the body. In this project, we wanted to monitor both biological and environmental conditions simultaneously, such as breathing patterns, skin temperature, human activity, temperature, and humidity inside the face mask, the position of the mask, including whether people are wearing it properly or not. Kim says, we also want to check the fit quality to integrate their sensor into face mask. The researcher created a device that they call a conformable multi-modal sensor face mask (CMAS) sensor that measures a variety of parameters are embedded in a flexible polymer frame that can be reversibly attached to the inside of any mask around the edges. To measure fit, the CMOS has 17 sensors around the edge of the mask that measure capacitance, which can be used to determine whether the mask is touching the skin at each of those locations. The CMOS interface also have sensors that measure temperature, humidity, and air pressure, which can detect activities such as speaking and coughing. And accelerometer within the device can reveal if the wearer is moving around. All of the sensors are embedded into an biocompatible polymer called polyamide, which is used in medical implants such as stents. The researcher tested the CMOS interface in a group of 5 men and 5 women. All of the subjects wore surgical masks, and the researcher monitored the reading from the sensor as the participants performed a variety of activities such as speaking, walking, and running. They also tested the sensor in a variety of temperature conditions using data obtained by the capacitance sensor. The researchers created a machine learning algorithm to calculate mask fit quality for each subject in the study. The measurement revealed that mask fit was significantly worse for women than men due to gender related differences in face shape and size. However, the fit for women could be improved slightly by wearing smaller surgical masks. The researcher also found that mask fit quality was low for one of the male subjects who had a beard, which created gaps between the mask and the skin. To verify this result, the researcher also collaborated with the MIT Environment, Health and Safety Office on the design and evaluation of the fit and found that the fit result for each study participant were very similar to what they found using the C mask. Customized fit. Okay. The researcher hoped that their findings will encourage mask manufacturers to design masks that fit a variety of face shapes and sizes, especially women faces. DAC Devian Lab is planning to work on mass production and large scale development of the CMOS interface. We hope to think about ways to design masks and come up with the best fit for individuals. Davidian says, we have different size for shoes and you can even customize your shoes. So why we can't you customize and design your mask for your own health and for societal benefit? The researcher also hope to return to the original idea of studying the effects of air pollution on people who work outside. And technology can really help to quantify the social cost of these environmental hazards and also to measure the benefit of any kind of policy intervention, Zhang says. I mean, Great, man. Great. Moving on to our next topic. New data transmission record set using a single laser and a single chip. Sorry, single optical chip. An international group of researchers from Technical University of Denmark (DTU) and the Chalmers University of Technology in Gothenburg, Sweden have achieved dazzling data transmission speed and are the first in the world to transmit more than 1 petabit per second p-bits using only a single laser and a single optical chip. 1 petabit corresponds to 1 million gigabits. In the experiment, the researchers succeeded in transmitting 1.8 p-bit, which corresponds to twice the total global internet traffic, and only carried by the light from one optical source. The light source is a custom designed optical chip which can use the light from a single infrared laser to create a rainbow spectrum of many colors, that is many frequencies. Thus, the one frequency color of a single laser can be multiplied into hundreds of frequency colors in a single chip. All the colors are fixed at a specific frequency distance from each other, just like the teeth on a comb, which is why it is called a frequency comb. Each color of frequency can then be isolated and used to imprint data. The frequency can then be reassembled and sent over an optical fiber, thus transmitting data, even a huge volume of data, as the researchers have discovered. One single laser can replace thousands. The experimental demonstration showed that a single chip could easily carry 1.8 bits, which, with the contemporary state of the art commercial equipment, would otherwise require more than 1,000 lasers. Victor Toda's company, professor at Chalmers University of Technology, is head of the research group that has developed and manufactured the chip. What is special about this chip is that it produces a frequency comb with ideal characteristics for fiber optical communication. It has optical it has high optical power and covers a broad bandwidth within the spectral region that is interesting for advanced optical communication, says Victor Todd's company. Interestingly enough, the chip was not optimized for the particular application. In fact, some of the characteristic parameters were achieved by coincidence and not by design, says Victor Torres company. However, with the efforts in my team, we are now capable to reverse engineer the process and achieve with high reproducibility micro comms for target application in telecommunications. Numbers potential for scaling. In addition, the researcher created a computational model to examine theoretical the fundamental potential for data transmission with a single chip identical to one to the one used in the experiment. The calculation showed enormous potential for scaling up the solution. Professor Lev Kutso and Ozen Lowe, head of the Center of Excellence for Silicon Photonics for Optical Communication, spoke at DTU, says, our calculation says that with a single chip made by Chalmers University of Technology and a single laser, we will be able to transmit up to 100 p-bits. The reason for this is that our solution is scalable, both in terms of creating many frequency and in terms of splitting the frequency comb into many spatial copies and then optically amplifying them and using them as parallel sources with which we can transmit data. Although the comb's copies must be amplified, we do not lose the qualities of the comb which we utilize for spectral efficient data transmission. So these are the study given by our researcher on the new data transmit record by. Sorry guys, sorry. I'm in so hurry, so really sorry. There is a lot more in this article, so read it. This is how you pack light with data. Packing light with data is known as modulation, of course. Here, the wave properties of light are utilized, such as amplitude, the height, strength of the waves, phase, the rhythm of the waves, where it is possible to make a shift so that a wave arrives either a little earlier or a little later than expected. Polarization, the direction in which the waves spread. By changing these properties, you create signals. The signals can be translated into either ones or zeros and thus utilized as data signals, reduce internet power consumption. The researcher solution bodes well for the future power consumption of the internet. In other words, our solution provides a potential for replacing hundreds of thousands of the laser located at internet hubs and data centers, all of which guzzle power and generate heat. We have an opportunity to contribute to achieving an internet that leaves a smaller climate footprint, says Lev Kutso Ozenlo. Even though the researchers have broken the petabit barrier for a single laser source and a single chip in their demonstration, there is still some development work ahead before the solution can be implemented in our current communication system, according to Lev Kutsio Ozenlov. All over the world, work is being done to integrate the laser source in the optical chip, and we are working on that as well. The more component we can integrate in the chip, the more efficient the whole transistor will be. That is laser creating chip, data modulators, and any amplified elements. It will be extremely efficient optical transmitter of data signals, says Lev Kutso Ozenlov. The research is published in Nature Photonics. Moving on towards next topic. Uh, Human vision, a challenge for AI. Of course, man. So let's see. What's author trying to tell us? Achieving diversity in human vision is one of the major challenges for AI research. In the vast majority of our cases, we are better than machines at understanding the world around us, but machines are catching up slowly but surely. Within a single day, we humans can go from driving a car to free driving and continue to reading the newspaper and navigating a dense forest, all without a great deal of effort. For a robot doing the same thing would currently be impossible, says Mikhail Felsberg, professor at Linköping University and one of the Sweden's foremost researchers in computer vision and artificial intelligence AI. That we humans we do all this and much more is largely due to vision. Estimate says that some 80% of our impression reaches us by way of our vision. It is a single most important sense for preserving what happens around us. Mikhail Felsberg research focuses mainly on what is called the artificial visual system, where the aim is to get computer to see as well as human do. Biological systems simply work. Humans are remarkably skilled in general perception and analysis skills we want to emulate in computers. Today we can build technical systems that are good at doing a particular task, such as self-driving vehicles. But if in the future we want to be able to collaborate with robots, they must be able to see and understand exactly what we see, says Mikhail Felsberg. Imitating human vision might seem easy at first glance. When AI research began, the feeling was that computer vision would be solved with single camera, maybe a project for the summer break. Now, almost 60 years later, general computer vision has developed into one of the more salient challenges in AI research. The code is the brain. Mikhail Felsberg and his co-workers test many of the solutions they develop in the Vision Laboratory on campus Vela in Linköping. For instance, between the huge glass walls, autonomous drones and small self-driving cars equipped with advanced sensors and cameras are test-driven. But the actual brain in the computer vision is behind the lens. The camera is just a light sensor. It can't do anything else. The actual work is done by the code, the software behind the camera. Of course, the camera is just a light sensor. Yes, it can't do anything else. Of course, the actual work is done by the code and the software behind the camera. Yes, it's the same with people. The eye registers the light and the brain does the work, says Mikhail Felsberg. There have been many attempts to emulate the human brain with varying results. Today, a method of machine learning called deep learning is usually is usually used, but simply it means that the computer learns, it models organized in neural networks from large amounts of data. The algorithms are fed with huge amounts of data, which are analyzed on several levels. This might sound complicated, and it is. The truth is that no one can say exactly what happens in every activation in a deep network. Mikhail Felsberg draws parallels to the human brain. On a brain scan, you can see which parts of the brain are active during different stimuli, but we still don't know what actually happens and how a thought is formed in the brain. Deep learning works is a somewhat similar way. We see that it works, but not how it works in detail, he says. The way forward. But why is it so difficult for a computer to see what we see? The answer lies in our ability to rapidly adapt to different situations and the feedback loop between our perception of our surroundings and our constantly active cognitive ability. Looking out through a dirty window pane is an everyday example of a situation where computers struggle, but we humans manage swimmingly. We see immediately what's going on outside the window despite our slightly obstructed vision. On the other hand, a computer will first autofocus on the dirt on the plane, but once it has found the right focus on the scene outside, it still won't fully understand what is happening because some of the view is blocked by the dirt, of course, man. Still, there are areas where computers already see better than humans, in particular when it comes to exact calculation and assessment of distances, temperature, and patterns. In these cases, computer vision can complement our own vision rather than draws its own conclusion and act on them. A technical system works well as long as everything is as expected, but faced with something unexpected, it will have problems. We must work to make the system more robust, says Michael Felsberg. But developing software that can surpass the flexibility of human vision takes time, and according to Mikhail Felsberg, research must take time if it is so to be robust. Science is a process, and every new research article adds another little piece to a massive puzzle. Breakthroughs that give research a huge leap forward are very rare. General situational awareness in a computer could possibly exist in our lifetime, but creating the link between cognition and general situational awareness in a computer is probably very far off in the future, says Mikhail Felsberg. Once general computer vision exists, he believes there will be many different applications. Example: social robots, safer autonomous vehicles, and more efficient production. Of course, man. But AI is not uncontroversial. Many fields of use risk encroaching on individual privacy when large volumes of personal data are processed. For this reason, Mikhail Felsberg and his research team are focusing on how AI can give better insight into how we prevent additional climate change. Climate change is one of the humanity's greatest threats. Using advanced computer vision, we will be able to rapidly analyze large tracts of land and their importance for the climate. What would take humans several years to map out manually could potentially be finished in a few weeks with the help of AI. So these are the things. These are the study on the human vision challenge for the AI by the Mikhail Felsberg. Moving on to our next topic, Australia flags new corporate penalty for privacy breaches. It's a news, so let's read it. Australia on Saturday proposed tougher penalties for companies that fail to protect customer personal data after two major cybersecurity breaches left millions vulnerable to criminals. Of course, man. The penalty for serious breaches of the Privacy Act would increase from 2.2 million Australian dollars, 1.4 million now to AU 50 million, $32 million under amendments to be introduced to Parliament next week. Attorney General Mark Dreyfus said a company could also be fined the value of 30% of its revenue over a defined period if that amount exceeds AU $50 million, $32 million. Drifters said big companies could face penalties up to hundreds of millions of dollars under the new law. It is a very new, substantial increase in the penalties. Drifters told reporters it is designed to make companies think. It is designed to be a deterrent so that companies will protect the data of Australians. He added. Parliament resumed on Tuesday for the first time since mid-September, since Parliament last said unknown hackers stole personal data from 9.8 million customers of Optus, Australia's second largest wireless telecommunication carrier. The theft has left more than one third of Australia's population at heightened risk of identity theft and fraud. And non cybercriminal this week demanded ransom from Australia's largest health insurer Medibank after claiming to have stolen 200 gigabytes of customer data including medical diagnosis and treatment. Medibank has 3.7 million customers. The company said the hackers had proved they hold the personal data for at least 100. The thieves have reportedly threatened to make public medical condition of high profile Medibank customers. Dreyfus said both breaches have shown existing safeguards are inadequate as well as failing to protect personal information. The government is concerned that companies are unnecessarily holding too much customer data for too long in the hope of monetizing the dead information. We need to make sure that when a data breach occurs, the penalty is large enough that it's really serious penalty on the company and can't just be disregarded or ignored or just paid as a part of a cost of doing business, Dreyfus said. Dreyfus hopes the proposed amendments will become law in the final 4 weeks that Parliament will sit this year. Any new penalties will not be retroactive and will not affect Optus or Medibank. So these are the penalties charged on the corporate who's not able to secure their data or secure their user data from the cybersecurity aspect. It's a great and it's an important thing right now because many cybersecurity attacks going on in the world on the different authority and on different countries. So it's a good initiative by the Australian government on this aspect. So yep. At last, I just want to say, you guys, keep researching, stay curious, stay healthy.